Hello guys, welcome to my channel. Thank you for tuning in. If you are new here, don't forget to follow me on Facebook and TikTok, Trockers, as well as subscribing to my YouTube channel, Trockers. Oh, today without wasting much of our time, we want to talk about rates of change. We are talking about rates of change here, right? Remember, we need to understand what rates of change is, and also we need to go to the question. Our question is the radius are centimeters of a sphere. So here it's talking about a sphere, right? The of radius r centimeters of a sphere is 10 centimeters, and it is increasing. It is increasing at the rate of 0.25 centimeters per second, right? Then we need to determine the rate of increase of the volume and of the surface area, right? So now let's tackle this question. But before we do that, guys, we need to understand what rates of change is. So rates of change, it just tells us about how a quantity changes as we change another quantity. So for example, we might have a relationship between the area of a circle, right, and its radius. So we might say area is equal to pi r squared. So we want to see how the area is affected by the change in what? By a change in radius. So if we increase or decrease the radius, how is the area going to react? So that's all about rates of change. That's all about rates of change here, guys. Right, so with that being said, let us now move on to the question. So we need to solve our question here. Right, so the question, it reads, the radius r of a sphere is 10 centimeters and it is increasing at the rate of 0.25 centimeters per second. So we need to write that down, right? So we are given that the radius here, our radius is 10 centimeters. That's the given information, right? Then it is increasing. So what is increasing here is the radius. So my dr radius with respect to time. So everything, if there is an increase or a decrease of something, we are comparing it with respect to time, right? So it's dr dt is equal to 0.25, right, centimeters per second. And again, remember centimeters here, they are equivalent to radius, then seconds here, it's time. So it can also help you, like these units can also help you to write the correct differential part here, right? So we want to find, so in this case, on part A of the question, we want to find the rate of increase of volume. So we need to find dV dt. And on part B, we need to find the rate of increase of the surface area. So I can call it S. So it's ds dt. So these are the two rates of change that we need to find. So now let's start. We know that the rate of increase of radius with time is this, and we need to find our dV dt, and it's now talking about the volume, right? And we know that the volume of a sphere here, so my volume is 4/3 of pi r cubed, right? So first, we need to differentiate volume with respect to radius. So we need to find our dV dr. So our dV dr here, if you bring down that, is 3/4/3 pi r squared, which simplifies to 4 pi r squared. So usually I encourage you to plug in this value, which is just 4 pi 10 squared, which is 400 pi, right? So remember, this was volume with respect to radius. This was volume with respect to radius. So volume, as you can see, the units for volumes, guys, is cubic. Then radius is just centimeters. So here we remain with what? We remain with square centimeters. That's the what? That's the rate of change of volume with respect to radius. Then we now want to find dv dt. So to find our dv dt, right, we apply the chain rule. Remember, dv dt is equal to, the given was dr dt divided by dv divided by, because we want it to be dv dt, so divided by, I keep change flip, yeah, divided by dv dr, because here when we say dr dt divided by that, we're going to keep, you change and you flip, right? No. So if I say dr dt divided by this, it doesn't work. Okay, what if I say dv dt divided by dv dr divided by dr dt. So if I keep this, I have my dv dr times dt dr. Again, this is not working. Okay, so let's do it the other way around. So it's gonna be dr dt times dv dr, right? So to get that, it's dr dt times dv dr. All right, that's okay. So here, let's go ahead and multiply instead of dividing. So here it's multiplying, both the drs will cancel out. So my dr dt is given here as 0.25 centimeters per second multiplied by dv dr, it's 400 pi square centimeters. So now if I calculate here, right, 1/4 of 400 is 100. So I like to believe this is 100 cubic centimeters per second. And as you can see here, these are cubic meters. That entails us is we are dealing with volume. Then S here, we are dealing with what? We are dealing with time. So this is part A of the question, where we found the rate of increase of volume with respect to time. So now let's move on to finding the rate of change of surface area here. So the given information, I can write it down again. Our radius was 10, our dr dt was 0.25 centimeters per second. So we know that the surface area here, right, our surface area is equal to 4 pi r squared. So first, we need to differentiate the surface area with respect to our radius, right? So which is 8 pi r, and we know that our pi is 10. So here it's 80 pi, right? But remember, these are square centimeters divided by that. So the rate of change of surface area with respect to radius is 80 pi centimeters, right? Now, let's see how we get our ds with respect to time. So our ds with respect to time is ds dr times dr dt, because when these r's cancel out, we remain with ds dt. So it's now 80 pi, right, centimeters times 0.25 centimeters per second. So 80 times a quarter of 80, that's 20. So it's 20 pi square centimeters per second. So these units, guys, are very important. It's 80 pi 20 centimeters. And as you can see, these units here, the square centimeters, obviously tells us that this is an area. Then seconds here, it's what? It's time. So basically, that's how we solve these problems, guys. Thank you so much for watching. Just continue to search for more videos. Have a good one.